Good afternoon, physics class. So today we're going to be working with constant velocity and learning how to calculate that graphically and algebraically over the next few days. So the way we're going to do that is we're going to start with a lab. So along with this lesson, there are going to be 3 slow motion videos. You're going to track the distance and time of a tennis ball rolling down a hallway, and there are going to be distance marks every 10 centimeters. So what you're going to do is watch each of these 3 trials and record the time at which the ball crosses a few different thresholds, where it crosses the starting line, so the beginning of the paper chart, when it crosses the 30 centimeter line, 60, 90, 120, and then 150 centimeters. Each of the 3 videos represent your 3 trials. All right? So the first thing you need to do is set up your data table to look like what I have here, where I have my 3 trials, trial 1, trial 2, and trial 3 at the top. We're going to be recording those values in seconds. So I want you to write the units underneath, seconds, seconds, and seconds. So what you're going to see in the video is a little stopwatch. Because it's slow motion, you can't look at the time of the video. You're going to look at that stopwatch to find out the exact time that the ball crosses each of these lines. So if you have trouble seeing the numbers in the video, just remember it's marked every 10 centimeters. So after the start, at the beginning of the paper, you're going to wait for the ball to move across 3 lines, and then once it gets to the 3rd line, that's 30 centimeters. 3 more lines, 60 centimeters. 90, 120. And 150 is the last line that you're going to record for in slow motion. Okay? So I have some sample data here that I'm going to use. This is not data that's reflective of the actual YouTube video. So to get the real data and to get credit for it, you're going to have to watch the videos and do your best to figure out at what time the balls cross at each of the 3 trials. So I'm going to put in my sample data now so you can get a sense of what this looks like. So for my first trial, I have my ball crossing the starting line at 1.5 seconds. Okay. And then it crossed 30 centimeters at 1.75 seconds, and so on. So remember, this data is not from the videos. In order to get your data, you're going to have to watch those videos and pause the videos when you see the ball crossing each of these thresholds and record the time you see on the timer that's also in the video. All right, in my second trial, the ball crossed the starting line at 1.4 seconds. It crossed 30 centimeters at 1.7 seconds, and so on. So it might be you're going to have to play with the slider on the video so you can get the ball as close to these lines as you can. You're not going to be able to get it perfectly, but we slowed it down so that would be easier for you to see when the ball crossed each threshold. So trial 3 crossed the starting line at 1.6 seconds. Like that. Okay, so now that you've seen how to set up your data table and how to input your data, I want you to pause this video, set up your table, and then open up the first trial and start adding in your data. Okay? And then come back once you've done collecting your data. So pause right here. All right, so now that you've collected your raw data at the top here, your raw data, now we're going to make a second data table, okay? The reason for that is since we couldn't start the timer exactly at the starting line. We had to start the timer a little bit before the starting line. The result is that each time the ball crosses the starting line in the beginning of the paper, the timer was at a slightly different time. Okay? But in order to figure out how fast the ball is moving, we want to give every ball the same starting point so we can really compare it. So that's what we're going to do on this bottom table. Okay, so bottom table looks similar to the top table, but notice that in addition to the three trials, trial 1, trial 2, and trial 3, we have an average as a fourth column. Okay, and under distance, we're still doing centimeters, but you see we're going to be finding the time from the start. So for each entry, we're going to subtract the starting time. Okay, so I'm going to show you how to do this with my sample data. Remember, this is not the data you should be using for your data tables. You should be using the real data from the videos. Okay. But the way you would want to do it is that for each trial, you're going to take the value from the data table up top, and you're going to subtract the start time. So 1.5 minus 1.5, in this case, is 0. All right? So that's going to be the case for each trial at the beginning. We want to start each one at 0. 1.4 minus 1.4 is 0. 1.6 minus 1.6 is 0. Okay? So now we're going to do that for the other time. So for trial 1, 30 is 1.75 seconds. What we're going to do is subtract 1.75 from the starting time, which is 1.5. So we're going to do 1.75 minus 1.5. Okay, and that gets us 0.25. If you can't fit all the subtraction in here, that's okay. Just write down your answer in this square. If you have to do the subtraction off on a separate piece of paper or in your calculator, that's fine. But in this box, I want to know what the difference is. So next, 60 was 2 seconds. So we're going to do 2 seconds minus 1.5 seconds, which is 0.5 seconds. 90 was 2.25 minus 1.5. That gets us 0.75 seconds. I'm doing this subtraction in your head. If you want to do the subtraction in your calculator, that's totally fine. 2.5 minus 1.5 is 1.0 seconds. And 2.75 minus 1.5, 1.25 seconds. Okay, so you're going to repeat that process for each trial using that trial's starting time and subtracting it from each distance's recorded time. So we're going to fill out the 30 across all of them. So trial 2 hit 30 centimeters in 1.7 seconds. We subtract that from the start time. 1.7 minus 1.4 is 0.30 seconds. Okay, and for trial 3, hits 30 centimeters at 1.8 seconds. 1.8 minus 1.6 is 0.2 seconds. All right. So after you've done that for every trial in every distance, you're going to want to calculate the average for the 3 trials now that you've made each one start at the same point or at the same time, 0 seconds. So remember, to calculate an average, you're going to add up the 3 values and then divide by the number of trials. In our case, we're going to divide by 3 because there's 3 trials. So each value is 0, so we know the average is also going to be 0. No need to put that in the calculator. That's what we wanted. We wanted our start time to be the same so it's more easy to compare. In our second trial, we've got 0.25 plus 0.30 plus 0.20. So that comes out to 0.75. And remember, once we've added it up, we're going to divide by the number of trials. In this case, we're going to divide by 3. 0.75 divided by 0.3 is 0.25. If you need to use a calculator to do that, that's totally fine. So the average for trial 1, 2, and 3 at 30 centimeters is 0.25 seconds. Okay, great. So you're going to, once you finish calculating the average for each distance across the 3 trials, take a photo of your raw data and your time from start data, upload those, and you'll be done with today's assignment. Great work.